Hello everyone, so in this video I am going to try to validate the best I can the TF-IDF calculation I did with Natural Language Toolkit. I had to make some slight changes to the source code, and I thought this would be a good opportunity to sort of show how you can find your installed packages, at least in Anaconda, and also go over that log thing that we were talking about in the last video. Is it base 10? Is it base E? And I think that's about it. So let's get into this. So to do this, I think I'm just going to start by just typing some code, and then we will see where the problem is that I'm talking about. So first, we're going to need to import NLTK.text. So from NLT.text, we're going to want to import, text collection. That's what we're doing here. Now, so obviously this means you're going to have pip install NLTK. So for example, in PyCharm, if you're using PyCharm, you can go and view the project, and go to the interpreter, and you can see I'm using Py 3.6, and here's all the installed packages that I have. So if I scroll down here, I can see that I have NLTK installed, as well as things like Flask and whatnot. So you just want to make sure that you also have NLTK package installed, in order so that you can import and use some of its features and stuff. So let's get going. So we're going to import that first, and then it's really simple. We're going to instantiate a new object called myTexts, and it's going to be instantiated from the text collection class. And maybe if you're used to instantiating objects in programs like C# or Java, you have to put the new keyword in front or whatnot. But in Python, you don't have to do that. You just set it up like this, and we will pass, into the constructor the sentences in this case. So we're going to have to pass a list of the sentences. So I'm just going to scroll up and grab this list of our documents and pass it in. And I'll show you where all this stuff is in the source code in a moment. So if I just backspace this just to make it, I don't know. I like to have things, there we go. Just makes more sense to me here. This is on one line. So now we've got a myText object that we can call the TF-IDF method on. So if I take myTexts and I go dot to access the methods, you can see that it's actually the first one that comes up, TF-IDF, and we have to pass it the term, which is going to be universe, and then we need to pass it the sentence that word is in. So we'll take this sentence right here, and we will pass that in, and it's a string, so I'm going to grab the string, okay, and I'll paste that right here. And let's also, we're also going to print out our calculation that we did in the last video and compare it to this calculation. So let's actually print this out. Let's print that out as well. And then let's run this program and see what happens. So there's a little bit of a delay here in the calculation. There it is, finally pops up. So here's our calculation, and we use the word universe here, and we see that our TF-IDF calculation is 0.1569. But when we're using NLTK, we see it's actually a different number, right? That's this print statement here. Maybe I can make this a little more obvious. Print TF underscore, NLTK TF IDF. And if I run this again, we'll see it prints out. There it is. So you can see here that this is not the same as this. So initially when I saw this, I was like, oh, I'm doing something wrong. So I was just gonna look into the source code of NLTK and see where the differences are. And I actually discovered something interesting. So let's do that now. So if you're wondering where your package is installed to from Python, what you can do is you can go to your C drive, go to your users, go to your account. You need to have your hidden folders shown because you need to get into app data. And then you go into local, and then we're going to go into Conda because I'm using an Anaconda environment. Then we go into my environments directory, and then I have two environments on this laptop, which is Py 3.6, so we'll go into that one. Then we need to go into the lib directory, and finally here we will find the site packages directory, and this is where all of your installed packages go for this environment. So if we scroll down and we're looking for NLTK, okay, there it is. So if we open this up, and then we scroll down, because if we remember here, we from NLTK.text. So now we're in the NLTK directory. .text is right here. And I will just open this with Visual Studio Code. And that's how you can view the source code of this class, or of this package. And we're looking for the text collection package. But first, just to discuss that little issue we were having last time with, let me open this project, and let me just open this up. Okay, here it is. So we've got, if we scroll down here, I was not sure in the last video, was this log base 10 or log base E or log base 2? And then I realized, and I put a little note in the other video, that actually in the example down here, they actually do say using base 10 logarithm. So I'm still using base E. But if we look at the source code, we can see that they've imported math import log, which is exactly the same thing as what we've done here, math.log, right? They've just, instead of doing math.log, they've imported log, and then they just use log. Now, where am I looking here? If we look for the log portion, here it is, math.log. So they've just imported the same thing, log. And then if we keep looking at this source code, if we go to that text collection, so if I, there it is, there's the text, here's the text collection class. And here's an interesting thing, they've put in a comment here that it's a prototype only, this will be slow to load. We did notice that little delay, so that might explain that. But if we scroll down, we can see that this class has a couple of methods. Here's the constructor, here's the TF calculation. I added this, I'll get into this a little later. And we got the IDF and TF-IDF. So for their IDF calculation, see, they are only using log as well. So, you know, just like I did, they just used log, and they haven't done the comma base 10. So for example, and then here it is, 2.7.15, but of course I'm using, I'm using 3.6, so let's change it to the 3.6. And if we scroll down and we look for log, we can see here that, you know, but the same as in the last video, so by default it's to base E, but if you want the log base 10, you have to go log X and then comma 10. That would be log base 10. So I assume, if you look at the source code again, since we see log and we don't see comma 10 or comma anything, that they're using the base E for this calculation. So again, I'm still uncertain what log base I should be using for this calculation, or if it even matters at all. So that's still a question that I have. But I just wanted to come back to that because that was something I was discussing in the last video. But okay, anyway, so what we're going to see here is, right, so getting back to this difference in numbers for TF-IDF, it happens to be, you know, if we look at the TF-IDF method that we called, we passed in, right, the object itself. That's how Python works. You have to pass in the object and then the term in the text. So in our case, that was universe and the sentence that that universe is in. So if I just flip back here, this is what we passed in, universe, and then that sentence. So then it takes those, multiplies them together, right? Because, you know, you take the TF method returned results, and then the IDF, which is exactly what TF-IDF is. So this is all making sense, right? If we look at the calculation, TF-IDF is just the product of TF and IDF, which is great. Multiply those together. So if we see how they're calculating term frequency, we can look at this method. And we see that it is calculated by taking the text.count of the term in the text. So how many times, now that part makes sense. How many times does this term appear in the text? And then they divide it by the length of the text. Now, the interesting part here is, so term frequency can be calculated in multiple ways. You can just get the raw count, which is just the number of times that term occurs, or you can do the term frequency adjusted for document length, which is what I did. So I took the term and I divided by the number of words in the document. However, you can also do this logarithmically scaled one, or this augmented frequency one. So there's multiple ways to calculate term frequency, and this might just be another way. But to keep it consistent with how we are calculating it, we need to divide it by the number of words in the document. And this returns the number of actually characters. So this could be an issue with how I'm passing in a list of strings. Maybe I need to pass in a list of tokenized words. Maybe that's what's supposed to be passed into here. But it's a simple fix. I can just, you know, split on the spaces and then pass that into here. Now, this might not all make sense. It's a lot of talk, so I wanted to show you what I meant. So if I go back here, and let's make our own little method here. Let's make our own little method called test_ term frequency, and let's pass it the same things. Let's pass it the term, and let's pass it the text, because that is what is passed in, and this is supposed to be a method. So let's just define this method and then put a colon here. And now let's print the length of the text, right? So if we print the length of the text and we pass in this text, what we're actually going to get is all of these characters. So if I now run test underscore TF and I pass in the term, so in this case the term, well, essentially what we want to do is pass this directly into it. So now we're kind of replicating, and what we can do to truly kind of replicate what's going on here, let's go back to the source code. We can see, let's return the text.count and let's return the length of the text just to see what those numbers are. So if I go print text.count and let's count how many times that term appears. So the term universe appears in the text only once, so we should see 1, and then we should see the length of the text. You know, we would expect it to be 1, 2, 3, 4, 5, 6, 7, right? But we're not going to get that, so let's run this and see what we do get. So right, so the first part works, the count, right, of universe is just 1, but then see, it's 36 characters, and that's because if we count every single character in here, right, so 1, 2, 3, 4 spaces are included, 3, 4, so 5, so 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So it counted all of the characters. Now, my guess is you're supposed to pass in probably like a list of tokenized words or something rather than an entire string itself. But it's an easy fix. All we have to do is just uncomment. I just made this here. So what we'll do is we'll just split it on the spaces, exactly like we did when I was calculating term frequency up here. So the first thing I did was tokenize the words by splitting it on the spaces. So that's the first thing I did. So all we have to do is do that again here. Take the new text, pass that into here, and then let's save it. So now let me copy this. And let's see what happens. So if I take this and we put it into our little test function down here, if I take that and put this here, and then instead of printing the length of the text, I print the length of the splitted text here that's split on spaces, and we run this, there we go. Now we get 7. So now that we have this proper length that I've adjusted in the source code here as well, we should get a similar number. So if I just comment out, you know, this method, because we don't need to call this anymore, and we're still doing this with the new code, if I rerun this, we will see, there it is. So we see now the calculation that I did here, 0.156944 matches 0.156944 with NLTK. So that's perfect. So that's good. Let's try to validate this a little bit more. Instead of just the universe, let's try the word the, because in my calculation it should be 0. So let's see if NLTK matches that. And it is, which is good. And let's try one more. Let's try vary. Varies TF-IDF is 0.0579. So let's grab that and put that into the NLTK. Let's do that. And there it is, 0.057923. And 0.057923, which is great. So I think what we've got here is we've at least sort of validated that my calculation is correct with NLTK. And it gives me a little more confidence that maybe this is working. There's one more thing I wanted to show. I was curious, you know, in the thinking about looking at this source code here, if other people had this issue or were confused by it. So I looked at the GitHub. So if we just Google it, it's the first one that pops up. And then we scroll down here. So again, this is what kind of a normal GitHub page looks like. So if we kind of scroll around, we can see that here's the README and stuff. So what we can do is then look at issues. And the reason I'm showing you this is just in case you run into these sort of similar issues and you're kind of looking to see if other people have noticed it. So I just typed in TF and searched for it. And yeah, it looks like some people were talking about this issue. Now, I realized that this actually is not, I think what they're talking about here is term frequency usually is just the raw count rather than divided by the length. I think that's what they're referring to here. Of course, it is sometimes that is the case if it's the raw count, but other times it's divided by the length. And there's sort of a discussion happening here on, okay, so what's the best way to define term frequency, and what is it? And I feel like essentially this is what we ended up doing, except that in my case I passed a string which took the characters rather than the words. So it was interesting. It was sort of just an interesting thing to see here, and people are talking about it, so that's kind of cool. So I'm so happy for everyone who has stuck with me till the very end here. So thank you so much. I'm very happy if people have stuck with me till the end for this whole series. I hope this has been helpful, and please correct me if I've made mistakes along the way. And if you're liking this content, please like and subscribe.